Hello everyone. So welcoming you back in a new session of Propositional Logic and Hardware. Almost 70-80% portion of this chapter we already finished. Each and every topic I covered in the previous videos. So if you want to check what is adders or the basic connectives, which are also called operators, or the truth table proof of the algebraic expression, the Boolean expression, or the algebraic proof of the Boolean expression, what all things are given, everything is given in a separate video. So well, you can go through it. So today's session is the continuation of the previous videos only, where we discuss some of the questions from the unsolved exercise. So yeah, today we are going to start with question number 40. So for the same, so yes, now the 35 question, 35, 36, 7, 8, these all questions we finished already. Today we have to start with question number 40. Again, I am saying these all questions are based on the chapter content. So if you are not clear with the chapter content, you will feel a little uncomfortable to do these questions. So better you just make yourself comfortable with the portion, with the laws, with the algebraic proof and the truth table, and then you can go directly with the questions. Okay, so this is question number 40. As you know, the bar thing I am not able to type, so now only I am going to insert the bars. State De Morgan's law, verify them using the truth tables. So De Morgan first law is, it is P plus Q bar. Okay, P plus Q bar is equal to P bar dot Q bar. So here it is, we have P and this one is P bar, we have Q, then we have Q bar, and this is P plus Q whole bar, and then we P plus Q. Okay, first we will go for P plus Q only. Just a minute, I'll remove it. Okay, and even the color of the pen also I can change the ink color to blue. Okay, so well, let me write down again. So this is P and P bar, Q, Q bar, and P plus Q, then P plus Q bar, and then P bar dot Q bar. So let us go with the truth table of the same. So we have P and Q. So 4 inputs will be there, starting with 2 zeros and 2 ones. Okay, then we have, this is P bar. So just the opposite, bar is something, it is going to negate the input. So 0 to 1, 0 to 1, 1 to 0, and 1 to 0. So next to that we have this one, Q. So Q is 0 is there, 0, 1, 0, 1. Then Q bar is 0 to 1, 1 to 0, 0 to 1, and 1 to 0. Then you will find P plus Q. So P is here, P is, this one is P, this is Q. 0 plus 0, plus is, if any of the one input is true, it will give you the true output. So we have P and Q. So 0 plus 0 is 0. 0 plus 1 is 1. 1 plus 0 is 1. And 1 plus 1 is 1, right? Then bar is there, which is just going to negate the values. 0 will become 1. Then 1 to 0, 0, and 0. Now you have P bar dot Q bar. So this is P bar and this is Q bar, and dot is there. That means if both of the inputs are true, then only you will get true answer. Otherwise, false only. So P1 dot 1 will give you 1. 1 dot 0 is 0. Then 0 dot 1 is 0. And 0 dot 0 is 0 only. So now you can check this P plus Q bar is LHS. And you can check P dot Q bar, this is RHS. And then check the values. Both are same only. So hence proved, right? So we proved the first part of this one. Let us start with the second law of De Morgan's. So again we have to fill with bars. So P dot Q whole bar is equal to P bar plus Q bar. So again the same thing, P is required, then P bar is required, then Q is there, then Q bar is required. Then P plus Q is not required, it is P bar plus Q bar is required. And then P dot Q and then P dot Q whole bar. So let us start. P is 0, 0, 1, 1. Q is 0, 1, 0, 1. Then P bar is the opposite of P. So opposite is 0 to 1, 1 to 0. So 0 will become 1, 0 to 1, 1 to 0, and 1 to 0. Then Q bar also the same thing, 0 to 1, 1 to 0, 0 to 1, and then 1 to 0. Then you have P bar plus Q bar. So this is P bar, this is Q bar plus So if any one is true, it will give you true result. So here we have 1 plus 1 is 1, 1 plus 0 is 1, 0 plus 1 is 1, and 0 plus 0 is 0. Then you have P dot Q. So P dot Q, this one, these two. And again, if both are true, then only the output will be true, otherwise false. True is 1 and false is 0. So 0 dot 0 is 0, 0 dot 1 is 0, 1 dot 0 is 0, and 1 dot 1 is 1. Then bar of this is just the opposite of the value 0 to 1 and 1 to 0. So 0 will become 1, 0 to 1, 0 to 1, and then 1 to 0. Now you please check P dot Q whole bar. This is P dot Q whole bar is LHS. And then we have P bar plus Q bar. P bar dot Q bar is RHS. Now you please check the values. These two values are same. So hence proved. So this is the truth table proof of De Morgan's law, which is very, very important, right? So let us move to our next question. This is question number 40, A part. Now we are moving to question number 40, B part. I'm changing again to some red color. Okay, and let us start. So let me check the question. It is 40 B part. 40 B part is A plus B and A bar plus C. Okay, A bar plus C is equal to A plus B plus C plus dot A plus B plus C bar. And the third is A bar plus BC and A bar plus B bar plus C. So yes, let us start. So now you can see first is this is the left hand side part. Okay, A plus B. A bar is also required. So this is actually A dash. Okay, and BC. So A dash is opposite of A. So 0 to 1, 0 to 1, 0 to 1, 0 to 1, 1 to 0, 1 to 0, 1 to 0, and 1 to 0. Now A, B, C, all the three inputs are there. So if you will go only for the left hand side part, so A plus B is required. This is A and this is B. Plus sign is there. So if any one input is true, it will give you true output. So 0 plus 0 is 0, 0 plus 0 is 0, 0 plus 1 is 1, 0 plus 1 is 1, 1 plus 0 is 1, 1 plus 0 is 1, 1 plus 0 is 1, and 1 plus 0 is 1. Then next to that you have A bar plus C. This is A bar plus C, right? This is A bar and C. So these two, if any of the one is true, it will give you true result. So 1 plus 0 is 1, 1 plus 1 is 1, 1 plus 0 is 1, 1 plus 1 is 1, 0 plus 0 is 0, 0 plus 1 is 1, 0 plus 0 is 0, 0 plus 1 is 1. Now we have what? We have one dot in between. This is A bar plus C, right? So in between, if both are true, then only you will get the true result. So let us check these two are true. 1, 1, and here also 1, and here also 1, and rest everywhere you fill 0. So this is a shorter way. So we found the answer, the truth table value 0 and 1 for LHS part. Now moving to the right hand side part. For right hand side part, I have written here again. So let me write down the expression, the right hand side expression one more time so that we can just check whether we are doing the things correctly or not. So the right hand side part of the same question is, it is A plus B plus C dot, we have A plus B plus C bar dot, we have A bar plus B plus C dot, we have A bar plus B bar plus C. Okay, now you can check we have A, B, C, all three are there, but bars are also required for A, B and C. So these three values are the bar which I already filled. You can see A bar is just the opposite of A, 0 to 1, 0 to 1, 0 to 1, 0 to 1, 1 to 0. Like that only B also I filled and C also I filled. Now we have to find the value of A plus B plus C, the first three, okay? So if any one is true, it will give you true result. 0 plus 0 plus 0 is 0. Then 1, 1, 1, 1, 1, 1, 1. Okay. Now we have A plus B plus C bar. So this is A, this is B, and the C bar, this one. So first two and the third, the last one. So 0 plus 0 plus 1 is 1. 0 plus 0 plus 0 is 0. Then 0, 1, 1. Then 0, 1, 0, it's 1. 1, 0, 1 is 1. 1, 0, 0 is 1. Then 1, 1, 1 is 1. And 1, 1 and 0 is 1. Now the third third part of this complete expression is A bar plus B plus C. So well, A bar is this only. This is A bar. So we have to go for this, this and this. A bar plus B plus C. The middle three. So we have 0, 0 and 0, 0 and 1. So 0, 1, 1, 1. Then 1, 0, 1 is 1. Then 1, 1, 1 is 1. And here only you have 0. And rest everywhere you have 1. Now the next is we have A bar plus B bar plus C. So this is A bar, B bar and C. You can see A bar, B bar and C. So the third, fourth and fifth column, right? This is C and A bar and B bar, right? So again I am repeating, these three we are going to cover, these three, right? 0, 1, 1 is 1. Then 1, 1, 1, 1. Then 0, 1, 1, 1. 1, 1, 0 is 1. Then 0, 0, 1 is 1. Okay, and then 1, 0, 1 is 1. 0, 0, 0 is 0. And then the last is 1. Now they all are adding with this dot sign only. So if all are true, then only you will get a true result. So well, wherever you are feeling the 0 is there, so just fill it 0, 0 and 0 and 0, right? And rest everywhere the 1 is there. So yes, so this is the final output in which we are getting first two zeros and then two ones, then 0, 1, 0, 1. Let us check with the, so first two 0, 1, 1, 0, 1, 0, 1. This is perfect only, and both of the values are matching for the left hand side and right hand side. So this is the perfect proof of the given expression. Moving to the next question. So we have 40C part, full adder. They are asking for draw the logic circuit for a 40. This is 40C part. Give the truth table for a full adder. Here it is. I have given the truth table here, but if you want to go for the complete expression of the full adder, better you can go with the previous video. In part 4 or 5, I have explained only the adder thing, the half and the full adder. The complete explanation is given with the the explanation, the theoretical explanation with the symbolic diagram and the truth table. So I'll suggest you to go with that, and if you are interested, I'll share the link in the description box. Okay, so moving to the next question, which is 40D part. Draw the circuit diagram for the Boolean function f x y z is equal to x bar plus y bar plus z using NOR gate only. So well, NOR gate, for NOR gate directly also, if you are comfortable, you can go for NOR gate. Otherwise, if you are comfortable to draw with the help of the basic gates, so first you can draw with the help of basic gates, and then you can just replace all the basic gates. Remember, the basic gates are AND, OR and NOT. AND, OR and NOT. So these are the three basic gates. So later on, what you can do, you can just replace all the AND, OR and NOT gate with the help of NOR gate. So let us start with this. You have x plus y. So I'm starting with the directly with the NOR gate only. So this is the OR gate, and to make it NOR, so you will just give a circle here. This is NOR gate, and what is the input is x plus y. Let me check the input properly. It is x dash plus y, okay, x bar plus y and y bar plus z. Okay, so x bar is there, so you know very well you have to draw one small NOR gate here just to make it bar, right? So this side you have x, this side you have x bar, and y directly we can give. Okay, so this is done. Then one more is there, so you please draw it again, the NOR gate. I'm drawing it here, and this is NOR gate, and this is y bar. So for y bar, you again draw this one NOR gate just to make the y input as y bar, and z is the normal one only, just make a straight line and z. Now you can join them together, and again you have to use one NOR gate, and you are done. NOR, and this is the final output. Okay, you can write fxyz or this expression, anything is fine. I'm just going with the output because this is the final one. Okay, so we are done with this fourth part also, 40D. So moving to the next one, we have 41A, and 41A is just they are asking you to state the distributive law and to verify it with the help of truth table. So well, the distributive law is P Q plus R is equal to PQ and plus PR. Okay, distributive law, P Q plus R is equal to P dot Q plus P dot R. Second is P plus Q dot R is equal to P plus Q and P plus R. So let us go with the truth table explanation of this one. So this is using TT. TT stands for truth table. Please don't get confused. Okay, so we have P dot Q plus R is equal to P dot Q plus P dot R. So let us start. PQR, three inputs are there. So I'm just writing PQR. And for three inputs, you will take the same only, 4 zeros and 4 1, right? Then 2 zeros, 2 1, 2 zeros, 2 1. And then the alternate one, 0 1, 0 1, 0 1 and 0 1. Now what you will do, you will find Q plus R. So please check it out. Q plus R, if any of the one input is true, it will give you true result. Well, 0 plus 0 is 0 only, and rest everywhere. Here also we have zeros, and rest everywhere we have 1 true. So it will give you Q plus R. Then P dot Q plus R, okay? P dot Q plus R. So you have to do it with this and this. If both of the inputs are true, then only the true result. So 0 and 0 is 0. 0, so obviously 0, 0. Then here also 0, and the last three you can see all are 1. So 1, 1, 1. So this is the LHS part is done. Now moving to the right hand side part, we are starting with P dot Q. So again dot is there. So if both of the inputs are true, and the output will be true only. So here we have 0, then 0, 0, 0, 0, 0, and the last two are 1. Then we have P dot R. So P with R. Again the same thing if both of the inputs are true, right? So 0, 0, 0, 0, 1, 0, 0, 0, 0, 0, 1, 0, then 1, 0, 0, then 1, 1, 1, 1, 0, 0, and then 1, 1, 1. And now the plus sign is there. I'm just writing RHS. You please, this is the RHS, right? This is the RHS. So well, we have P dot Q and P dot R. Plus sign is there. If both are true, then only you will get, if any of the one is true, right? It is plus sign, any one. So 1, 1, 1. Now you please check it. This is the left hand side. This is the RHS. And the values are same only. So hence proved. So like that, I think we took the multiple questions. Actually multiple. We took all the questions. Okay. It's not the examples. We took the unsolved one. We took the solved one. So I hope you are clear with this. So P plus Q dot R is equal to P plus Q dot P plus R. Again using the truth table method. So P, Q, R. Start with this P with 4 zeros, fill it with 4 zeros, then 4 1, then 2 zeros, 2 1, 2 zeros, 2 1, then 0 1, 0 1, 0 1, and 0 1. Now Q dot R, right? Q dot R. If any one is true, output will be true, right? Sorry, if both are true, right? Both are true. This is and means both should be true, right? So 0, 0, 0, and here we have both 1. Then 0, 0, 0, here we have both 1, right? Then P plus, okay, P plus Q dot R, and this will give you LHS. So P and this, any one is true, plus sign, okay, 0 plus 0, 0, 0, 0, 0 plus 1, 1, 1, 1, 1, and 1. Okay, so this is done only. Now I'm checking for P plus Q, any one is true, and P and Q. So 0, 0, then 1, 1, 1, 1, 1, 1. Then we have P plus R, okay? So please find it out. P plus R. This is P, this is R. Any one, 0, then 1, then 0, then 1, then 1, 1, 1, and 1. Now we have a, dot sign here if both are true. So 0, 0, 0, 0, 1, 0, 1, 0, 0, and last 1, 2, 3, 4, 5. All true, okay? So you can check it. This is the LHS, this is the RHS, and both are same. So hence proved by truth table. So truth table, though we are expecting one question in exam also, even in algebraic way also. So most of the questions are based on truth table. Well, this one we are going to do it with the help of algebraic proof. So this is 41B, and it is given, the expression which is given is x plus x bar. So x plus x bar, right? So let me take in color black, and a pen is done. So yes, so we have x plus x bar y, right? It is x plus x bar y is equal to x plus y. X plus y. So I am to taking the LHS only for the proof this one. So we have what can be done. So x dot 1 plus x dash or x bar x dash y, same only, right? So x dot 1, obviously we can write x dot 1. So this is the property of x dot 1 is equal to x, which is the property of 0 and 1, right? Property of 0 and 1. So like that, you please don't forget to write the property name. It's compulsory for you to mention it, okay? Then x dot, as we have to add y also, so I'm just adding it 1 plus y, replacing this 1 with 1 plus y, and plus x dash y, okay? So 1 plus y, again it is a property of, so what can be done? 1 plus y is equal to 1. And this is again the property of 0 and 1. Okay. So I mentioned here. Now I'm just multiplying it inside. So it is x plus xy plus x dash y, right? So I just multiplied it here. And from these two we can take a common y. So y here, then we have x plus x dash, right? And then what can be done? X plus y, and x plus x dash is 1 only, which is the complementarity law. So please write it down here. X plus x dash is equal to 1, and this is complementarity. Complementarity law, yeah. So this is done only. And what you will do now? Obviously y dot 1 is equal to y only. I already written here only. This is the same property. Y dot 1 is equal to 1, and this is the property of 0 and 1. Okay, and this is equals to RHS, right? Proof done. Hence proved. So well, it's taking less time, but you have to be clear. Algebraic method is good only, but for algebraic method, you have to be clear with all the laws. That's the main thing, okay? They will cut marks if you will not mention the property properly on the right hand side of the same. So it's compulsory for you to give it, okay? Then I'm moving to the next question. We have the half adder, which is already done. If you are not done with the previous videos, please go through it. I'm going to share the link of the half adder and full adder in the description box. So next to this, we have the 41D part. Represent the Boolean expression x plus y, y plus z, and x plus z with the help of NOR gate. So I'm just directly going to do it. So just draw one NOR gate here. So you should be clear with NOT gate, right? So I am drawing it here now. This is the NOR gate, NOR. Okay, so this is X. We don't have any bar or anything. So 3 parts are there for each. You have to draw one NOR gate. Actually, it is OR gate, but OR gate will be replaced with NOR gate in case of if they are giving the expression, you have to draw only using the NOR gate. Okay, so this is Y, Z, and Z, X, and just join them together. And then the final output will be something like this. No, and this is the output. So well, we did so many questions related to this, so that's what I took a little fastly I finish it off. So I am trying my level best to give you a complete explanation with all the solutions of the questions. Still, if you have any doubt, you are free to ask in the comment box. And if you are really, wants me to continue with such type of videos with all the solutions of your unsolved questions, please don't forget to like, subscribe, and to share with others. This will motivate me to, involve myself to find time for such type of videos. Okay. Thank you so much. Bye.